Hello again. This is part 2 for heat transfer, the first sheet. Before going through the plane wall, I want to give you a quick explanation for the heat transfer on chipboard. On the ship, what are the examples you can see the heat transfer? For the engine room, the first thing for heating, you can see that we use the heat transfer in domestic water or in domestic purpose. The other thing is in fuel, that all of us, as known, that the fuel must be heated to a specific temperature before the injection process. The other way of heat transfer is the cooling for the engines, whether so for the main engine or the auxiliary engine. As you know, there is sea chest. We take water and goes through pipes, and we make the circulation for the cooling process. There are other type for the ships that use or some specific vessels that are fitted with waste heat recovery system for the power production. There are so many examples. You can see the heat transfer for on shipboard, but this is the quick examples. We can go now back to the sheet for the heat mode transfer. With the first thing we'll talk about the plane wall. So we will say that the sheet, there's two types, the conduction and the convection. These are the two main equations that we will use. The first one, as we explained on the other part, that the Q is the heat transfer rate. This is at the K is the constant, the area. Delta T is the temperature difference, and this is the thickness, wall thickness. Due to Ohm's law and the analogy between the heat transfer and the electricity, we prove that the Q equal delta T over R. Delta T is the temperature difference and R the resistance. How we calculate the resistance? The resistance is calculated, it is for delta X over KA. And for the convection, the rule is Q equal H, A delta T. Also, Q is the same, delta T over R, but here R is calculated in a different way. It is A, or it is 1 over H A. So now we will answer the first question in the sheet. Please concentrate with me. The example here, this is a very easy one. An outside wall for a building consists of 10 centimeter layer, common brick. So we come here, you write the givens. The first one is wall 1, it's brick, and the other one is given here that it's fiberglass having thermal conductivity 0.05 watt per meter Celsius. As we said that the K is a constant, it is given. So, and the wall is what? The wall is for 2.5 centimeter. So here you draw this, wall 1, wall 2, and you write down the givens. And also the temperature is 25 Celsius. And what is the required? The required is a calculate the heat flow. So you write here the given, the required is the Q, and here the rest of the givens. How we will start the solution? We will write our concept as this problem. It is for heat conduction and heat conduction. This is the first question, first equation that's used, and the R is the second equation that's used. Here the R, the resistance, the two walls are in series or in parallel? They are in series. So therefore the R total will be R1 plus R2. So if you go through the solution, you will find it is a direct substitution for the givens. And before we put, you have to know that the units used here, that the centimeter must be in meters, so you have to multiply by 10 power negative 2. The other thing that you have to know that we talked about, the area. The area has 3 cases. The first case of the area, it is given, or the second case, it is required, or the third case, it is not mentioned anything about it. So you will make an assumption that the area equal 1. So the first equation, first problem here in sheet 1 is a direct substitution. It's very easy. So we will go through the second equation, or I'm sorry, for the second problem in the sheet also you will find it is a direct substitution. Let's solve it together. The second one is A composite wall is formed of a composite wall. Means, what is the meaning of composite? Composite means it will contain many layers. The first layer is a copper for 2.5 centimeter, and after that you will find 3.2 millimeter layer, and the last part is 5 centimeter layer of fiberglass. So here you come and write the given, the first wall, the second wall, and the third wall. You write here x1, x2, and x3, but be careful that here the x2 is in millimeter, so when we use it in the solution you have to change it to meter, so you multiply by 10 power negative 3. And then the wall is subjected in the sheet, okay, it's here. The wall is subjected to an overall temperature difference for 560 Celsius. So temperature difference will be given Celsius. But remember here, there is something, a tricky little bit. The givens here for the K constant, constant is in Kelvin. So you have to change the temperature from Celsius to Kelvin by adding 273. Also here you will find what is the required. The required is Q over A. Here the required Q over A, so you don't erase or put any assumption for the area. It is required to have the final answer in Q over A. So you will go through here. For the first equation you write, it is required Q over A. What is the first equation we use? Q equal delta T over R. And how we calculate the R equal X over KA. So to calculate R total, it is in series or in parallel. We'll find that it is in series, so it will be also direct substitution. It's a very easy equation.